Hello and welcome to Algebra 2 tutorial. In this video, we are going to take a look at radian angles. So this is going to be a new way to measure an angle. Now, when we were looking at trig in the previous unit, we were all about the angles in right triangles. And so it's important for us to look at this new way of measuring angles. So the way we're used to is degrees. And in a full circle, there are 360 degrees. That 360 mostly comes from the fact that there's about 360 days in a year. But there'd be good to be a better way than to doing that because there's actually 365 days in a year, and we don't want to use that number. So we came up with this idea of the radian, which is a more mathematical definition of an angle. So we're going to take a look at what that radian is. How can we convert between this new radian angle and degrees, which we are more familiar with, and then we start using the all-important pi in these angles. And then because we're going to extend this and use this a lot, we have to be able to do negative angles and then large angles as well. So first, what is this thing called the radian? So a radian is an angle based off of the radius of a circle. So first, let's just take an angle that we're used to, something kind of like that. So there is an angle. That's sort of what we're used to. And what we're going to do is we're going to start building our angles inside of a circle. So I'll do my best here to draw a circle all around. Not very good. But we're going to start thinking of our angles inside of a circle, and this circle has a certain radius. Now we all think, look at this, and this is what, almost a 45-degree angle. We can sort of spot check that because we are familiar with degrees. We're not going to be able to do that with radians because it's a new unit of measure. Similar to say if I told you, hey, I'm going 60 kilometers an hour. You have no idea how fast I'm actually going because you're not familiar with kilometers an hour. 60 kilometers an hour is about 37 miles an hour. And as soon as I say 37 miles an hour, you kind of have an idea of how fast I'm going. We're going to have that ambiguity and that uncomfortableness for a little while with what a radian is. So I'm going to build an angle inside of a circle, and we're going to use the radius to measure how big the angle is. So let me get a demonstration of this because my handwriting is not good enough. So here is a much better circle. We have a radius. And so as we want to measure the angle, we are going to use the radius to measure the angle. And to do that, we wrap that radius around the circle till we get to there. And this angle right here, about here to there, ooh, that was bad. This angle right here is what we call 1 radian. So that is an angle of 1. It's very big compared to a degree. And then we keep going. We keep wrapping another radius around till it gets to there. Let's lock it in right there. This is now 2 radians. So this here is now an angle of 2. You can see they're much bigger than what we're used to with degrees. All right, and then we keep going around. This is an angle of 3. And here we feel like a little bit of disappointment. Man, it would be nice if that had been perfectly half a circle, wouldn't it? That's 3 radians. And I'm going to keep going around a little bit faster. I don't need to mark them all off. There's about 4 radians, 5 radians, and then 6 radians gets us to right there. So a full circle is just bigger than 6 radians. And just in case you think, like, man, what about the size of the circle? Doesn't that change things? It actually doesn't. If I make the circle bigger or smaller, you can see how they still stay along my colored lines there. This is still 2 radians. That is still 1 radian. And so the angle measurement doesn't change even if you make the circle bigger or smaller. Now, one more really important thing about these. It was sort of a disappointment that half a circle was not 3 radians. It was close, but it's even better than that. It's 3 and a little bit. So if I put it right there, that is, it's got a little bit of round off error with the number they're giving me. That is 3.14159 radians. That's where the number pi comes from. So half a circle is pi radians. And so a full circle all the way around will be 2 of those, 2 pi radians. And so that is where the number pi comes from. It's the number of radii that fit around half a circle. And there's 3 and a little bit, 3.14159. So that is how we are measuring degrees here, or measuring angles, not with degrees, but with these new things called radians. All right, so now that we kind of have an idea what a radian is, we got to be able to convert it back to degrees because that's what we're familiar with, and we'll want to think of both of them together for a while. So, how many radians is 58 degrees? So to do this, we set up a proportion. We take 58 degrees and we're going to compare it to a full circle, which is 360 degrees. So there we have a ratio of this part of a circle, the 58, to a whole circle. And I'm going to do the same thing in radians on the other side. Now I don't know how many is the 58 is going to correspond to, but I do know what a full circle is. So a full circle is 2 pi radians. And so how many radians over a full circle will equal 58 over a full circle? Well, to solve that, we've done that many times actually. We just cross multiply. So we get 360x is equal to 58 times 2 pi. So I need the calculator for that. 58 times 2 pi. There we go. Hit enter, and we get 364.42. Divide both sides by 360 to figure out what x is. So we get 364 divided by 360, and we get 1.01 radians. 1.01 radians. So 1 radian is pretty close to 58 degrees. All right, what if we want to go backwards? How many degrees is 2.7 radians? Well, here I'm going to basically set up the same thing. I don't know how many degrees there are, but I do know what a full circle is. And then I do know how many radians. It's 2.7. And a full circle in radians is 2 pi. So what I have to do now is cross multiply again, and this basically ends up being the same kind of problem. So I've got 2 pi times x is equal to 360 times 2.7. 360 times 2.7. So 972. Now I've got to divide both sides by 2 pi. And x is equal to, now I think this you have to be a little careful when you type it into the calculator. 972 divided by 2 pi. Got to put that in parentheses there. We get 154.69. 154.69. So there we can go from radians to degrees or degrees to radians, both directions, by setting up those proportions. You just take your angle and divide by a full circle. On the other side, you take your angle and divide by a full circle. So that kind of gives us an idea of radians as decimals. What we want to do now is switch gears a little bit and think of radians in terms of pi. This is where things are really going to fit much nicer. The decimals don't work nice, but decimals are easy to work with. The pi's work out much nicer. So we already figured out that this angle over here is pi radians. And we're going to start at 0, of course, but if we go all the way around, that is a full 2 pi radians. And so what we do is we start breaking this circle up into pi's instead of decimals. So if I take the half circle and I cut it in half again, which is, yes, 90 degrees, what is that in terms of pi? Well, it's half of pi. And so we just write that pi over 2. And then we count around the circle. This is 1 pi over 2. And technically you can think of this one as 2 pi over 2. But of course the 2's cancel out and just become 1, and so we simplify it. But think of it as a second as 2 pi over 2. Then this angle straight down is technically 3 pi's over 2. So we count 1, 2, 3. And then this one over here you could technically think of as 4 pi over 2. But the 4 divided by 2 simplifies back down to the 2. So we usually just write the 2 pi. Well, now we're going to continue that pattern. What if I cut things in half again? So what's half of a half? Well, that will be pi over 4. And now I start counting. 1 pi over 4. This one is technically 2 pi over 4. But hopefully you can see the 2 over 4 reduces back down to this. This one is 3 pi over 4. This one is technically 4 pi over 4, but 4 over 4 reduces, so I'm not going to write that one. So that was 4. This one will be 5 pi over 4. This one will be 6. I'll write this one, 6 pi over 4. Can you see that the 6 over 4 reduces down to 3 over 2? So we don't really need this one. So that was 6, though. So this one will be 7 pi over 2. And technically you can think of this one as 8 pi over 2, and the 8 divided by 2 reduces back down. So we can get all of these middle angles based off our 45 degrees, if you can recognize that, by using pi over 4. And they're nice and clean when you use those fractions. All right, I'm going to do one more set. Those are what we call all the pi over 4s. Oh, I just saw a mistake. Hopefully you caught it as I was saying it. That one should have been 4, shouldn't it? These are all the pi over 4 angles, except for the ones that reduce. Now we're going to do the pi over 6s. So I'm going to put the starting points. That's pi. This is 2 pi. This is pi over 2. And this is 3 pi over 2. And then instead of dividing these in half, I'm going to divide them into thirds. So how many pieces are we breaking up pi into? 1, 2, 3, 4, 5, 6. We're breaking it up into 6 pieces. So this is 1 pi over 6. This will be 2 pi over 6. This one will technically be 3 pi over 6, but it will reduce. This one will be 4 pi over 6, 5 pi over 6. This one is technically 6 pi over 6, and hopefully you can see that one reduces. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and last would technically be 12 pi over 6, but that reduces. Now, hopefully you saw some of those even I wrote down reduce. 2 pi over 6 is actually pi over 3. 4 pi over 6 is actually 2 pi over 3. Let's see, doesn't reduce, doesn't reduce, doesn't reduce. This one does, 4 pi over 3. And doesn't reduce, this one does, 5 pi over 3. That one doesn't. So this one gives us the pi over 6s and the pi over 3s when you reduce them. I would recommend using the pi over 6s more because you can just count 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. All right, so that is how we can count angles and circles with pi radians. It works a little bit better than using decimals. You might try filling them all in onto this circle. I'll fill in the first quadrant. Maybe you can fill in the others. This one is 0. This one is pi over 4. This is one of my 6's, so that's pi over 6. This one is 2 pi over 6. This one will be 3 pi over 6, which is just pi over 2. Maybe you can try to fill in the rest there. These ones are always going to be your pi over 4s, and the other ones are going to be your 6's, pi over 6's. And reduce when you can. All right, let's keep going. We got one more quick thing to look at. Negative and large angles. This isn't too hard, but it does make us practice our counting. So, first, negative angles. They're very simple. Just instead of going this way around your circle, for a negative angle, you count clockwise. All right, so I'm just going to count the same way but backwards. So where is 3 pi over 2? Well, this is 1 pi over 2, 2 pi over 2, 3 pi over 2. So if I go backwards, this one right here is negative 3 pi over 2. So where would negative 3 pi over 4 be? Well, again, I'm going to go around this way in the red direction, but now I have to count by pi over 4s. So here are all the pi over 4s. So I'm going to count 3 of them. 1, 2, 3. This is negative 3 pi over 4. So the negative just means you count backwards. All right. What about 10 pi over 3? Now here's where I would recommend, if you're going to mix pi over 4s and pi over 3s, I might recommend not mixing them and doing a new circle. They're kind of hard to count together. So the pi over 3s are very similar to the pi over 6s, and pi over 6s are easy to count. So I'm going to change this to 20 pi over 6. 20 pi over 6 is easier to count than 3s. So where is 20 pi over 6? So I'm going to draw in all my pi over 6s. All right. And now I just have to count 20 of them, and it's not negative, so I'm again going to go this direction. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that brought me to 12. I'm still not to 20, so I have to keep going. So 12, 13, 14, 15, 16, 17, 18, 19, 20 lands me right here. This is 20 pi over 6. And hopefully you caught there, I did a really big angle. Once I went all the way around the circle, I just kept going. And so if your number is bigger than one full circle, you just keep going around. And so we're going to use that for these ones. 43 pi over 4, I'm going to use my pi over 4 circle. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. That was 8. I got to keep going, and I don't want to count all the way to 43. So I'm going to count by 8s. That was 8 was one way around, 16, 24, 32, 40 puts me right here, 41, 42, 43. So this one right here will be 43 pi over 4. All right, let's do one more big one. It's a negative angle, so we're going to go backwards, and we're doing pi over 6s, so I have to use this circle. So if I go backwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't want to count all the way to 29, so I'm going to count by 12s. So one circuit around is 12, 24 gets me all the way back around, and then 25, 26, 27, 28, 29. So this one right here is negative 29 pi over 6. So that's how we deal with big angles and negative angles. All right, so that is a good introduction to the radian angle measure. Hopefully that makes some sense. We can think of it in terms of decimals, which is useful because decimals are easy, but after a while it's going to be very easy to think of this in terms of pi angles and just splitting up and cutting up that circle. All right, here are a few for you to try. Hopefully those make sense, and good luck.